When you're given a quadratic polynomial like this to factor, it's a little scary because notice there's a coefficient here. This coefficient means you're going to have to be doing a lot of trial and error if you don't have an algorithm, a surefire way to do this every time. Same with a problem like this. Anything that has a coefficient in front of the highest power is going to make the factoring very tedious. However, today, I'm going to use first principles to show you a way that can solve any quadratic polynomial as long as it's able to be factored. It'll save you time and reduce the number of trial and errors you have to do. So we're going to go through the first principles and we're going to learn this method. First principle from basic arithmetic, the commutative law. A plus B equals B plus A times B equals B times A. The order doesn't really matter. So we can add more things to add or add more things to multiply. Same thing. A plus B plus C equals C plus B plus A, which also can equal C plus A plus B, which also can equal A plus C plus B, right? Same with multiplication. A times B times C can equal C times B times A. It could also equal B times C times A. It could also equal A times C times B, etc., etc. This is called the commutative law. So this is the first principle. The second first principle is the distributive law. This is the one where if you have something multiplied by something inside the parentheses that's addition or subtraction, you just have to distribute, right? That's what's called the distributive. You have to distribute the value outside of the parentheses into it. A plus B, parentheses times C, means you distribute the C. So now, if we took an extra step on this and set C as equal to D plus E, then look what happens. We can distribute the D plus E the same exact way, right? So we just added another layer of distribution, but it's the same way. So A, this would be C, right? But C is replaced by D plus E plus B times C, which is also replaced by D plus E. So I'm keeping it at this form. Of course, you can distribute it again and you would get the final results. But essentially why I left it at this is basically how you FOIL. Do you guys remember FOIL? X plus something or 2x plus something or whatever x plus something times whatever x plus something, right? That's how you get a quadratic polynomial. So now let's apply this and let's FOIL. Let's multiply one of these. 3x plus 1 times 2x plus 6. And I put a C underneath here so you can remember the distributive rule, right? Essentially, you're just distributing this one into the 3x plus 1. Notice I wrote it here. And when you distribute it again, notice you get a second power, two first powers, and then a constant. The commutative law says we can switch these two. So I could write 6x plus 2x plus 18x plus 6. I mean, I could even write the 6 first, right? 6 plus 6x plus 2x plus 18x. So I can flip these around. There's a reason I didn't add these together. This is going to be important for later on. But remember, distributive rule, and then we could write this anyway, commutative rule. So now I'm going to add a letter for the coefficient and then a letter for the constant. So basically, this is the full, if we were to FOIL it, aka multiply them together, right? I just did it vertically this time, but it's basically the same thing. So mx plus n times px plus q would equal mx squared plus mqx plus npx plus nq. And again, we know the commutative law. We can switch the order of the addition, etc., etc. So what is factoring? In a quadratic polynomial, factoring is basically we're trying to get back to this form. So we're trying to unfoil, we're trying to undistribute. We just learned that multiplying this is basically using the distributive law. So if we're going to factor it to its original forms, we're going to undistribute. So how do you undistribute something complicated like this? Well, the first thing you do is you group. You try to group it in a way where you can take out things. So how can we group this in a way and take out things? Well, just sticking to how it is right now, I can see if we grouped it by this and this, and then this and this, we could probably take out some stuff, right? For example, what can we take out among these two? We can take out an mx. What about this? we can take out an n. That's exactly how I wrote it. Look, mx, and then the result is px plus q, and then this one is plus n and px plus q. If we use the commutative law and we switch these two, which I wrote here, what can we undistribute, so to speak, take out of this group? We can take out a px, and we're left with mx plus n. And here we can take out a q, and we're left with mx plus n. Notice we're trying to get back to this form, so then we can write it in this form. And what is this form? This is the end result if we factor it. So imagine this is d plus e, this is d plus e, a plus b. Another way to explain why we could get two ways of doing this is also to get back to this. Obviously, we can set this as c and distribute this into a plus b. We can set this as, let's say, f, and we can distribute f into d plus e. Okay, so the commutative law is involved and the distributive law is involved, and it seems like we're trying to undistribute or work backwards, but how do we do it? What's the secret? We're going to go back to this one more time, and we're going to do one more thing, which is we can take the x out of this and write it in this form right here. Why do I do that? Because this is where a really neat little thing can be observed. Watch what happens when we multiply these two values, so mq times np, and the coefficient of the highest power, so the second power, and the constant. If we multiply this together and we rearrange it in alphabetical order, it equals mnpq. If we multiply this together and we rearrange it in alphabetical order, it's also mnpq. And again, why can we rearrange multiplication, however? Because of the commutative law. It goes back to that first principle. mp times nq equals mq times np. Let's explain this in English. This is the generic form for a quadratic polynomial. Ax squared plus bx plus c, where a, b, and c are numbers. The a times the c, so the coefficient in front of the x squared, times the constant, equals the two numbers that make up, aka add to, b. The d and e just stand for two numbers that add to this coefficient and then multiply together equals this coefficient times this constant. So how does this make factoring easier? What do we do now when we get a complicated one like this that has a coefficient in front of the x squared? Let's multiply the coefficient in front of the x squared and the constant. So what do we get here? Negative 36. Now that we know it's negative 36, let's apply everything else we learned about this coefficient. Something plus something is negative 5, and that same something times that same something equals negative 36. So now we just have to figure out what numbers can add up to negative 5 and multiply to negative 36. This is the only step where we have to do a little bit of guess and check. After you do a little bit of guess and check, negative 9 times 4 equals negative 36. And if you add them together, you get negative 5. So now we can break up this into negative 9x plus 4x. So let's do it. Now here's the beauty. Remember the commutative law plus the distributive law? It doesn't matter which way you write it. No matter which way you write it, you're going to be able to group it, and you're going to be able to factor out the relevant thing, and you're going to be able to get back to this form. Let's do it both ways. If we wrote it this way and grouped it this way, here we can factor out a 3x. Here we can factor out a 2. And then this is the same. So we undistribute more, and we get 3x plus 2 times 2x minus 3. Those are our factors. In this case, if we switch the order, commutative law, here we can factor out a 2x from this group right here, and here we factor out a negative 3 from this group, leaving us with this as our c, so to speak, continue undistributing. So it would be 2x minus 3 times 3x plus 2. You get the same answers, just different order. So now we did it once. Besides the brief trial and error we have to do to figure out what multiplied together can also add to our b, aka the coefficient in front of our x, everything else, you can't go wrong. You can't do it wrong. So let's solve this together, shall we? Let's multiply the coefficient in front of the x squared times the constant. That gets us -8. So you don't have to write this out, guys. You can do this in your head. But some number plus another number equals 7. And that same number times that same second number equals -8. So that's the only trial and error you have to do. What added together, two numbers, equals 7, and multiplied together equals -8. How about 8 and -1? Those two added up become a 7, and multiplied together become a -8. You can write it as 2x squared minus x plus 8x minus 4, but I just assume that we're going to write it like this because we usually like to write the first bigger number in front. But if you wrote it the other way, it's fine too. Because of what we know about the commutative plus the distributive property, either way you're going to get the right answer. From this group right here, we factor out a 2x. From this group right here, we factor out a -1. And so now we work backwards again. And the factors we get are 2x minus 1 times x plus 4. First principles, we need to know how to add. We need to know how to multiply. And then we need to understand the commutative and the distributive laws. And from there, we can figure out how to multiply polynomials and get a quadratic polynomial. And then we can work backwards from there and we can factor. And the intricacy, the trick, the tip is there's a neat little property in quadratic polynomials where the coefficient in front of the x squared and the constant multiplied is the same as the two values that make up the coefficient in front of the x multiplied. So that's all you need. It's way less trial and error, much more algorithmic, and hopefully as you understand this from the first principles now and you practice this a few times, this becomes much easier and quicker for you in your future math journey. Thank you so much, guys. Hope this helps. Let me know if this helps. Let me know if you have any questions.